No, we're about to start.
So.
So I'll introduce you. This is Olivier. He's a research student. He is interested in malware domains, and that is all I understood from his abstract. So here he is to explain the rest.
Well, hopefully I can explain it.
Please, thank you.
So, well, welcome to my talk, Melting the Snow. It's about detecting snowshoe spams using active DNS measurements. Well, first, a little bit of an introduction. As the name tag says, my name is Olivier. I'm a PhD student at the University of Twente. And the work that I will be presenting here is been towards my master thesis, which has been completed in the end of August of last year, and has been submitted as a paper to NOMS and has been accepted in this time. I'd like to take the next half hour or so to present what I've done during that time. And first, a little bit of background information. Well, I think I don't need to explain what DNS is. I may need to explain what active DNS measurements are. Now, DNS measurements you can do in two ways, or at least two ways, in passive and in active. In passive, you're just looking at what is going out of your network in terms of DNS requests and what kind of answers you're getting in. And in active DNS measurements, you're actively querying authoritative name servers for their DNS configuration. Now, the term snowshoe spam may be less clear to you. I'm sure you've guessed that it's a type of spam. However, it is a hard to detect type of spam. The idea with snowshoe spam is that the spammer does not send a single or 1,000 messages from a single host, but tries to spread it out over many, many hosts. So instead, it would send a single email from 1,000 hosts, which makes those hosts individually hard to detect. Our assumption is that spammers want to use as many email best practices as possible, because that increases their chance of reaching your inbox. Now, sender policy framework is such an email best practice. It ensures that only your email servers are allowed to send email for your domain. However, this has as a consequence that spammers need to register a domain name and need to configure it. And since they want to be able to send email from many, many hosts, they also have a domain name with many, many records. And perhaps we can detect such a configuration. Now, since this was academic research, there had to be a research question. Our main research question was based on the hypothesis that the use of active DNS measurement is a good way to detect snowshoe spam domains. To validate this hypothesis, we've come up with the following research questions. First, how can we detect snowshoe spam domains through the use of active DNS measurements? Secondly, how can we automate the process? And thirdly, what are the advantages of this approach over other approaches? And that we quantify in two ways. First, in how large is the time advantage that we can gain, and secondly, how much more spam can we block because of this? Now, to summarize this for the paper, we've taken the research question: what is the advantage of proactive snowshoe spam domain using DNS data? Now, for an overview of what I've done, I want you to imagine that you are in a room, and in this room there's a desk. On this desk there's a black box. On top of this black box there's a red LED and a blue or a green LED. You assume that red is bad and green is good. And on the side,
cat in the box.
Sorry, what? Maybe. On one of the sides there's a slot for a cube. Now, as you look around the room, you notice that there's next to the desk there's a box with cubes in them. You take one of those cubes out, and you see that there's a domain name written on it. And you also notice that the size of the cube is exactly the same as the input for the black box. So you insert it. The green LED lights on. You take another cube from the box and you put it in. The red LED turns on. Now, as you do this, you notice that there's a notepad on the desk, because the domain you've just inserted, which gave the red LED, got written on a notepad. Now, you continue this practice until the box of domains is empty, and your list of domains is fully on the notepad. Now, in essence, we've now done what I've been doing during my master assignment. But what is actually happening underneath? So this black box, it is actually a machine learning brain. This means that just like a human brain, it needs to have a training in order to predict if something needs to light up a red LED or green LED. Now this box of domains, it needs to come from somewhere. It comes from the OpenIntel platform. I'll talk more about this later. However, I can tell you that the OpenIntel platform is a platform which does active DNS measurements for a large portion of registered domain names. In this notepad, it is actually a real-time black hole list. Now, an RBL is a DNS-based way of hosting a blacklist. Essentially, what you're doing is appending all of those domains, or making all of those domains that are on your blacklist resolvable under the address of your RBL. In that way, a third party can check if a domain is on your blacklist by simply taking the domain, prepend it to the address of the RBL, and try to resolve it. Now, our RBL has been put into practice in the serve mail filter. The serve mail filter is a spam filter which is run by SurfNet. The SurfNet is the collaborative ICT organization for Dutch education and research. SurfNet handles the email for many of their associated universities and academies. So this means that a lot of email goes through their filter, and there's also a lot of spam. In their spam filter, our RBL has been set up in such a way that emails triggering the RBL are made visible but do not affect the score, since the score determines if a message is marked as spam or deleted altogether. The score is based upon several tests, and every positive test increases the score. The SurfNet mail filter operators recommend the thresholds to use to mark an email as spam with a score of 5 or higher, and to delete it if the score becomes 10 or higher. While universities may change these thresholds, we stick to the recommendation in this presentation and in the paper. The steps of retrieving the datasets from OpenIntel to handing it to our black box for classification and adding it to the RBL happens automatically every day. This to ensure that the RBL is up to date and fresh. Now a little closer look to the OpenIntel. Wait, a little bit before. As I've said, it's the source of our data. The platform performs a number of fixed queries to more than 60% of registered domain names. And for these queries, you can think of the A records, the quad A records, the MX addresses, NS addresses, etc. All of that data is then saved in a Hadoop cluster and made accessible via Impala, a SQL-like interface. Now, a box of these cubes is what we call a dataset. Each cube can be divided in, but what are those cubes? Each cube can be divided into smaller cubes, which we call features. Humans like to think in text, whereas machines like to think in numbers. So this is the reason that we convert the source data into numbers. For example, the number of IP addresses or the number of IP addresses in the same subnet, in order to get to those numbers that computers like. While we have very simple features that simply count the number of occurrences, we also have a couple of features which actually parse the text records for their SPF records. And all of these features combined then forms one of these cubes. And based on these features, the machine learning brain makes its prediction. And we've made two types of datasets, labeled and unlabeled. The unlabeled datasets are used in the daily detection, and essentially we label them ourselves by the classifier, and the labeled dataset, which is used for training purposes. We do not process all of the domains. That would be crazy. I mean, in the .com zone alone, there are more than 2 million domain names. First, we filter out the domains using the technique called the long tail analysis. Now, what is the long tail analysis? As you can imagine with the name, long tail, hold on. Yeah, to explain what the long tail analysis is, I want you to imagine that this bird here is the DNS, ordered by the number of records in a domain. So in the beak are domains with only a few records, and in the tail there are domains with many, many records. Now, and as the name already says, we're looking at the long tail. We do so by filtering out domains at a certain threshold. Thresholds from very conservative, the 99.9 percentile, to less conservative, 97 percentile. We stop at 97 percentile because the domains that you end up with grows exponentially, and we want to be able to do our daily detections in a, well, timely manner. For the domains exceeding these thresholds, we compute the features, and and at this point we have a data set. Now, for the training purposes, we label the data set by checking if the domain is listed on a blacklist. And for the training purposes, we actually go even a step further by saying, okay, well, we take only the blacklisted domains, and we match them with an equal number of domains from the Alexa top million list. While this is no guarantee that the domains that are not listed are actually benign, the chance of them being benign because they're on the Alexa list is a lot higher than simply those domains that were previously unlisted in the original dataset. Now, this training dataset has been used to confirm that there is indeed a difference between normal domains and blacklisted ones. As you can see behind me, you see two cumulative distribution functions of these domains. And as you can see in the number of A records, there's a clear difference between normal domains and blacklisted ones. At 75%, there's a gap of 11 records. This means that blacklisted domains often have much more records than normal domains. And the same you can see in the MX distribution, where the gap is a lot wider at 98%. Now on to machine learning. Now that we know that there's a difference, we can try to detect this in a large scale. We do so by machine learning. We could also do this by making a signature and trying to match domains to that signature. However, there's a main downside of this, is that if the spam trends change, you need to make a new signature. And with machine learning, you can simply retrain your classifier and you're done. Now, I mentioned training of a classifier a lot, but what do I mean with that? Just like you and I had to learn equations in school, a machine learning classifier needs to learn what makes a blacklisted domain and what not. It does so, like many of us, by trial and error. It makes a model, makes a prediction based on that model, and if it guesses correctly, it's fine. If it guesses incorrectly, the model is adjusted and the circle begins again. Now, at the end of the process, you hope that the model it comes up with is accurately enough to tell if something should be blacklisted or not. Now, there are many algorithms to build these kind of models, but for my master assignment, I've trained and evaluated a great number of them. However, for the full details, I refer to the paper, and in the sake of brevity, I go straight to comparing the classifier types. However, let me first explain how these classifiers are rated. In the evaluation dataset, there are spam domains and ham domains, normal domains. Now, a classifier can guess correctly or incorrectly. If it guesses a spam domain correctly, it's a true positive. If it guesses incorrectly, it's a false negative. And for the ham domains, it's the same thing. If it guesses incorrectly, it's a false positive. And if it guesses correctly, it's a true negative. So let's skip to the top three. More than 13,000 domains are correctly classified as spam. Number 2 does even more. And number 1 does about 13,500 domains. That's great. But wait a minute. Is that the classifier that we want? I mean, think back to the false positives. Normal domains being marked as spam domains. This could mean that your important benign email gets marked as spam. I'm sure you don't want that. So this is the reason that we rate our classifiers by the precision metric, because it's more closely related to the number of false positives. Now if we include the precision metric and sort on it, you already see a completely different picture. We've chosen the edit boost classifier as our classifier of choice and tried to improve it, and we succeeded. Now if we compare that one to the support vector machine, which was the previous number one, you see that the number of true positives may be halved. However, the false positives have also greatly been reduced. As mentioned earlier, we've made an RBL to host our results. Every day we would retrieve a dataset from the Open Intel platform and filter the domains, hand it over to our classifier, and those domains that it was of the opinion that should be blacklisted, we put on the blacklist. Now these we compare to several other blacklists to see if we could detect them earlier than they could. Now we essentially have a couple of categories in which we can put these domains. This first category accounts for about 29,000 domains which have been detected and blacklisted in less than 2 days. The second category is more interesting because here the difference between detection and blacklisting is at least 2 days or more, and it accounts for about 2,000 domains. The last category is not visible here because it counts domains that have been detected by us but have not been blacklisted. Now if we zoom into the detection advantage, we can see that we still have 928 domains that have been detected 60 days before being blacklisted. And since these results are a bit older because of my master assignment being done, if we look at the current state, we're already looking at more than 180 days before they're being blacklisted. And these are the domains in total, and these are the other 3 categories. As mentioned before, our RBL has been deployed in serve mail filter, and initially we simply deployed it to see if the detections that we did were actually used. However, we could make a more interesting insights of our results. This graph is one of the nicest graphs from this presentation, or at least in my opinion. On the x-axis there is the observation days. For every day that we got email from the RBL or from the serve mail filter which have triggered the RBL, we would record the domains in the email and the score of them. And on the y-axis are a couple of domains to simply make the graph a little bit smaller. Now, if we plot the scores, you see the high scores in red, which are kept at 5, and the blue colors are, well, lower scores. Now, if we overlay the detection status, we can then again make these 3 categories that we have had before. In this first category, where the detection difference is less than 2 days, this accounts for 20 domains. 14 of them have an average score of above 5, or 5 or higher, and they account for about 1,200 emails. Second category is the category where the difference between detection and blacklisting is 2 days or more. In this category, we see 29 domains. 21 of them have an average score of 5 or higher, and it accounts for about 450 emails. And the last category, this time it is visible, is the category that have been detected only. It accounts for 64 domains, 39 have a score of 5 or higher, and it accounts for about 1,000 emails. Now the most interesting part for our research are the areas colored in purple, because here we can make a difference, because they have not yet been put on a blacklist, but we have seen them already. It accounts for about 1,000 emails. 450 of them have a score of 5 or higher. However, is that actually the interesting part? I mean, those are marked as spam anyways. It's actually the other 633 which have a score below 5 where we can make a difference if we increase the score of the RBL. Now these count for 52 unique domains, and only 13 of them have never appeared in an email scoring above 5. They account for 31 emails, and so these may be seen as false positives. Now this pool of 633 emails has been used to see how much more spam we can block if we increase the score of the RBL. At 2 points you would have already marked 300 additional emails as spam. And if we increase the score, of course, there's going to be much more messages marked as spam. However, time goes on, and now we can see that the amount has about doubled. Now for the conclusions. Going back to the research question of the paper, what is the advantage of this method? We can conclude that the foremost advantage is the additional spam being marked, the additional spam being blocked. And this is of course the result of being able to detect the domains before they are blacklisted. And this advantage can be as much as 180 days. The additional benefit of our method is that relatively little domain knowledge is required. Think back to that black box. As it lit up a red LED, did you know why it did? And was it necessary? Now for the future work, it is actually my PhD research. Basically we do the same approach, however we broaden it not to just spam but to other areas as well. And our goal is to detect malicious domains before they are used in an attack. And we could use your help in that. If you or someone you know faces attacks which make use of the DNS on a daily basis, we'd like to interview you. Because we want to know what kind of attacks exist and how they use the DNS. This leads me to my last slide. Oh, you can contact me on that email, by the way. Leads me to my last slide. I want to thank you for listening, and if you have any questions, I'll be happy to answer them.
You said there about spotting malicious domains before they do an attack. Aren't you into the realms of root crime? Because up until they've done an attack, they aren't malicious.
Yes.
There's a risk that people with valid uses of domains could suffer and have their traffic slipped a lot.
Yeah.
And Ash, in your case, you're using CertNet's using it, but
Mm-hmm.
things like this of the nature being rolled out, like the DNS blacklists. So then the implication for somebody trying to do some things on the internet is potentially that they can't do it because they're getting blocked, not because they've done anything wrong, but because they're seen to fit the profile.
Yes, that is very much a valid point. And we've also, a couple of research questions into the ethics of doing such a blacklist, because indeed this is a problem. And we need to think really hard about how we are going to approach this. And of course we need to make sure that if people are actually using the RBL that we create, that they also know this kind of implication. So for example, with SurfNet, it's now been awarded 2 points. So that means that if a domain is on the RBL, it's not automatically marked as spam. So additional tests need to give a positive result before it's marked as spam.
Another question?
I work for a hosting company, and I really don't want to host spam and scam domains. So last year we were researching how the actual domain name, the name itself, can be used for spam and scam. And we used machine learning again to analyze for scam domains. We actually caught like 25% of the domains that were going to be used for this,
Nice.
only by analyzing the names. Like you know that Amazon E is not Amazon, so
Yeah.
You can directly detect those things. Have you tried analyzing the actual names?
Not yet, but we do plan on taking that into account as well, because that could be a very interesting feature to add. Yes, definitely.
Here. Have you looked into any differentiation in between the different TLDs, for example, the GTLDs, which is kind of prone to attract spammers because
Well, we do scan them, and I think I've also